Hello everyone, welcome to the first recitation of this course, Python for Deep Learning. I'm Ipsita, and in this recitation, we'll be familiarizing ourselves with different Pythonic constructs and techniques that are used extensively in data loading and model development using deep learning frameworks. But before we deep dive into these concepts, here's a list of prerequisites that we expect the audience to fulfill in order to be successful in this course. First is having a basic knowledge about Python syntax and how to implement different programming constructs in Python. Secondly, the audience must be able to set up their own development environment, which in case of Python is being able to set up a virtual environment or a Conda environment and maintaining it, and installing different Python packages with different versions through pip and or Conda. Lastly, having a basic knowledge of object-oriented programming constructs like what are classes and what are member functions and what are member variables. If you seem fairly confident about your skills in these aspects, we can move on to what to expect from this recitation. Firstly, you learn how to import packages, which is essential packages from deep learning modules like PyTorch and TensorFlow. Secondly, what are the different formats in which data is stored and how they are streamed efficiently in Python. Thirdly, data containers, which are merely a representation of the data that has been loaded into the memory. Fourthly, data wrangling and batch operations, these are operations that operate on these data containers in order to modify or manipulate the data or filter the data in those lists and do them efficiently. Iterators and generators are Python programming constructs which are used by these deep learning frameworks for data processing and data loading. Lastly, how to debug your code in case you're stuck and you have no clue why your program doesn't work the way it does. So let's deep dive into these concepts without further ado. First and the most elementary thing is modules and packages in Python, which is basically importing or using the pre-existing code in certain packages. So the syntax is very simple. You just import the module and you'll have all the code to use. Supposing you've created your own module, and you need to load a very specific feature of the module. You can do that by the syntax. When you import, you say from the module name and import that very specific function or class that you need. Moreover, so if you're new to Python, I would recommend going through the Python standard library, specifically Python runtime services and operating system utilities, because it helps you interact better with the underlying file system and issue commands to your operating system. The other modules that you'll be frequently using is Numpy and Matplotlib, which are very common modules for Numpy is for housing data, storing numeric data, and Matplotlib is to visualize them. Lastly, PyTorch and TensorFlow, which are deep learning libraries that you will be using. You'll be encountering them later, so we shall not dive deep into them. Typically, I would like the aim of this recitation is to equip you with the techniques that are used to load the data from the data source and to manipulate or how to filter out or manipulate that data to suit the format that is needed to feed to these deep learning models. So if you're new to Python, please pay very close attention to the techniques that are being used, because even in Piazza, we'll be just mentioning the techniques, but how to go about the underlying implementation, you will be familiar with it if you go through it right now. So firstly, the data sources and the common data store formats, which is How do you load the data from a certain file where your data is stored for training? Um, Typically, your numeric data is stored in a .npz file, which is used to store arrays of numbers. Multi-data, which is you have rows, or each training instance is basically a combination of strings, numeric data, um, enums, or different kinds of data. So that multi-type data is stored in CSV files, plain text in .txt file, and large data sets, generally when you're storing like billions of videos or uh, very heavy data, then generally HDF5 format is used. We'll be dealing mostly with pickle and CSV. So pickle is the way to serialize or deserialize a Python object. It's particularly useful if you want to store an intermediate state of your program and not want to lose that and load it later. So supposing you just import the pickle module and you have an Python object, which is essentially a dictionary. We'll come to that later, what a dictionary is. But yeah, this is the object. You just say pickle dump that object into a file called store.pkl, and later on you load it using the same file, and this is typically a different object, and you get the same data loaded in the new object. The other format being CSV. What's noteworthy is this syntax is common for opening any file for reading or for writing. So we are using this to read a CSV file, but you can read a txt file with this format as well. You're just creating a file object out of this file name, and you're reading, and you get a reader, which is basically an object to iterate through each and every row in your CSV file, and then we're printing it out. So this is general syntax to load data and uh, read data from a data source and load it into memory. Once you've loaded into the memory, how is it data stored in memory? What are the formats that the data is stored in memory? So data containers basically are the answer to that question. So there are Python offers different kind of data containers. There's lists, which is a very generic container which can contain different kinds of data, and all of them are indexed numerically. You have tuples, which are basically immutable lists. So once that, if you've created a tuple, it can house as many data, but you cannot change that tuple later on. You cannot add or delete elements from that tuple or change elements. Dictionaries are basically key and value pair. Like here you had key age and value 23, you had another key, you had another value. So dictionaries are key and value pairs, and sets are nothing but lists but with unique elements. So majorly we'll be focusing on lists and tuples because that is what you'll be using extensively in across all your assignments. Lists can be homogeneous or heterogeneous. They can store different kind of data. What is the most commonly encountered data type that you will be using is a tuple list or just a list. But a tuple list is something like, so if you can see, this is a tuple. Basically anything within these sort of brackets are a tuple. So you can see a consistency between the format across this. So all these are tuples, and these are multiple tuples stored inside a list, which is denoted by these square brackets. So basically you have a list of tuples, which is a tuple list. This format you'll encounter a lot in later stages, wherein your batch of data that you'll be loading into the model is basically a list of tuples, where each tuple represents your training instance, and a training instance can have different features. So the tuple represents that. Now, what are the operations that you can perform on these elements? Now, what if when I had a homogeneous list, what if I multiply it by 2? It's not that all the elements get multiplied by 2, it's just that it duplicates the list and appends it. So you get a new list with double the length. When you add two lists, basically it just appends one list to another. These are the arithmetic operations. The other common list operations, which is basically sorting and finding the sum or maximum minimum, you sort of like call them, you have sorted and sum and max functions, which you call in the list, and they work as expected. Once you are done with arithmetic and the list operations, the other operations is conditional filtering, or filtering in general. Basically, I want a certain set of elements in the list, a certain subset of elements. How do I extract it? So there are two ways. One is where I know the indexes that I want to extract, and that index-based method is called slicing and dicing. And the other way is I have a condition, and the elements that satisfy this condition are going to be extracted. So that's condition based, and that's done through list comprehension. So firstly, slicing and dicing is done in the following way. The syntax is somewhat like, I know the start index, I know the end index where it should end, or the elements till what part I want the elements to be fetched, and I have a step function. Basically, I want after every third element or every fourth element, so that step value indicates what the jump should be. So here, in case you can see, you have a homogeneous list. If I want the first 5 elements, I have something of this syntax. You can note that start index is, if the start index is missing, it assumes it's the beginning of the index, so I get the first 5 elements. Here you can see that there's a negative value. Negative or minus anything always means that index from the last position. So -1 means 85, -2 means 17, -3 means 66. So basically it's saying start from the last position and go on to the 0th index and skip every 2 steps. So skip backwards every 2 steps. So what it does is I'll get a list saying 85, then skip 2 steps, which is 66, then skip 2 steps, which is 78, and then 45. So this is essentially what I'm getting here. So these are the methods of extracting elements when I know the indexes and the pattern that I'm supposed to extract it. What do I do when I have to encounter a certain conditions or satisfy a certain condition? In that case, here the syntax is, the method is called list comprehension, and the syntax is somewhat like this, wherein you have a transformation, iteration, and filter. So what are these? Iteration is wherein you iterate through every element of the list, and filter is a condition where you say, okay, I need elements greater than 50, like in this case. So for every number in the homogeneous list, if that number is greater than 50, then store that number in this list. So if you see, I have filtered out all the elements that are greater than 50 in the homogeneous list. Now, why is list comprehension important? I could have, like, I have this syntax, I could have had another syntax saying for I in the range of, or for every element, I can just have an empty list and keep appending to it. The thing about Python is list comprehension is relatively fast than just appending it, like most Java people from Java background would do. And you can see that it's almost like half the time here, and although it's in milliseconds, it's significant when you're dealing with like thousands and 10,000s of data. So I always use list comprehension instead of iterating this way. Now, a typical use case of list comprehension, again, why list comprehension is important and how you'll be using it is here. So you have a batch data set, which is from the data source. I kind of loaded the data set, and as I said, your data set will generally be a list of such tuples, where each tuple is, say, a complex list of different kinds of objects. Like this is an array, this is just an integer. I this is basically from uh, ASR or transcript generation from your audio. So the data is something like your audio, which is in terms of frames per second. You basically record the audio, the frequency of per frame, and this tells me how many frames are there, and this is basically the corresponding letters to those audio, and this tells me the entire speech, how many letters does it have. So as I said, this is an array, this is an integer, array, integer. Now the operations that you can perform on that batch data set is you can sort it. Now supposing I want to sort it based on the transcript size, or like the utterance size, then what I do is this is the sorted function that we saw earlier, but along with the list I give the key value, which basically tells me for every x it represents a tuple in the list. So every second element of the tuple in the list, I should compare it and then sort the list. Similarly, for finding the maximum element, the transcript with the maximum length and the length of the transcript, actually, I supply x of 3, which is the fourth element. So find the maximum uh, uh, object with the maximum transcript length, and then give me the length of that, which is this 3 that represents here. Lastly, list comprehension, as I was saying, is very important. Here, if you can see, I can, supposing I just want to filter out the transcripts, I have the data in this form, but I just want, for some reason, just the transcripts and the transcript size for each and every list. So what I do, I iterate through the list and I just extract the elements that I want, which is the third and the fourth element, or the second or the fourth, third index elements. Also, you can carry out certain manipulations on the data set, on each and every tuple. Say I have instance represents a tuple, and I want to like transpose every like transcript value in that instance. So I can carry out that manipulation and create a new array. So these are the kind of things that you'll be doing sufficiently in your preceding assignments. So please bear these in mind. Also, you have the concept of classes in Python, but the most important, one of the most important classes are making iterators. Um, that's essentially because in PyTorch you have the concept of data sets, which is how do you iterate through this loaded data in your memory. So they generally do not deal with lists, but they have something as iterators and iterable, which essentially is an abstract data type, your customized abstract data type, or which maps to a container in Python, and every iterator should definitely have these three functions. So whenever we ask you to create an iterator, you should immediately have these three functions outlined. And so supposing this is useful when you have like 2-3 lists coming from different data sources, and you have supposing say label for those training instances coming from another different source. I can store them in my iterator, and whenever they say, okay, get the item at this index, I can just fetch it, or I can pass it as a tuple with that index at every list position. So PyTorch operates this way. The length function basically tells me how many elements are there in my iterator. So these three functions, whenever they ask you to create an iterator, which will be the case when you have to create a data set, always make sure that these three functions are well implemented. The other way is, instead of creating a class, you can also always have you can also have a function instead of a class, which in Python is called a generator. Uh, so generators generally relieve the developer of um, the overhead of keeping track of the state of the iteration. So when you're iterating sequentially through a data set, uh, instead of keeping track of which iteration it is in, generator handles that internally. What are generators? So simplistically, the syntax is nothing different. It's just like a function in Python, just that instead of the return statement, you have the yield statement. So like in this case, I have a pairwise generator which takes in a data source, and what it does is it iterates through the data source and yields every consecutive element. So by consecutive element, I mean every pair following pairs. So you can see here I have data, say 1, and the word for it. Now if I try to print this out, I create a generator, pairwise generator, and I instantiate pairwise generator function, and I have a generator. And when I say, okay, for every element in the generator, I need to print the element, you can see I have them as individual tuples, from a list to individual tuples. So generators are the other way to replace iterators. So you can iterate through two ways, either through a class, create an iterator class with length and get item functions, or you create a generator. Lastly is debugging in Python. This is a helpful tip in the sense that if you don't know what's going on or what state your internal data is, since you're processing a lot of data, you can always import PDB, which is a module for debugging, interactive debugging, and pdb.setDays, and say basically whenever the program runs or comes up till here, it'll stop and you can it basically creates a checkpoint, and from there on you can trace the execution. So say here n gives you the next step. So I get yield, which is, it will yield the data 1 1. Essentially it's loading 1 1. So this is what elt will be. So the value of elt here will be 1 1. But when I say input data at the ith stage, um, yeah, when I say input data at the ith stage, here I get 2. So again, when I say n and I say elt is set to 2 2. So basically I can go through the entire stack trace this way, and once I'm satisfied and I just want the program to run through, I just press C and it finishes. So you can see the entire flow, which function is being executed when and what is being returned. So this was essentially the basics that would help you get started. Hope you like the video.